All right, so this is S of 3.4, section 3.4, part C. This is more kinematics, more examples of kinematics. Let's say for our first example, a particle moves along an axis, just one, a particle. We'll say a coordinate axis, like maybe it's going back and forth along X. This is like moving in a straight line along something. And it's moving in the positive direction. Or to the right. Its function, position function, S of t equals t cubed minus 4t plus 2. And our goal is to find V1 and A1. Okay. Pause the video and see if you can do that. We did stuff like this in the last section, so you might be able to do this. All right. And then once we have this, we're going to have some more questions, and we'll answer them when we get it. So to do this, velocity v of t is s prime of t. And if we take the derivative of this, we get 3t squared minus 4. And if I take the derivative again, acceleration is the derivative of velocity with respect to time. This is just 6t. And now that I got my functions, we need to find these at t equals 1. So v of 1 equals 3 times 1 squared minus 4, which is negative 1. And a of 1 equals 6 times 1, which equals 6. So what is v of 1 telling us? V of 1 is negative, which means its velocity to the right is negative. Which means it's not going to the right, which means it's going to the left. At t equals 1. So its normal direction of travel is this way, but at t equals 1, it's going that way. This is like the overall. But when we look at acceleration, a of 1 equals 6, which is positive. It's greater than 0, which means it's accelerating to the right. Which means acceleration is going this direction. So I'm going, if I'm have a speed or velocity in one direction, but I'm accelerating in the opposite direction, it means I'm slowing down. The particle is slowing down. And this occurs when velocity and acceleration have opposite signs. Okay. All right, let's do another one. For this example, S of t equals t cubed minus 9t squared plus 24t plus 4, and we're going to say time is greater than or equal to 0. We want to A, find v of t, and B, when is the particle at rest? Then C, what time intervals doesn't look like a interval, that look like a W. Is it moving from left to right? And then how about from right to left? And then after that, what we're going to do is we're going to use that information to sketch the path of the particle. All right, so pause the video. You know how to find the velocity. Take the derivative and find the velocity. All right, I'll assume you paused it. S prime of t equals v of t, which equals 3t squared minus 18t plus 24. And that was A. Find the velocity function. B, at rest means is the same thing as when the velocity equals 0. It's resting, it's not moving. So what we do is we set this equal to 0. And I'm going to factor out a 3 right now because I think it's going to be a little easier to do everything if I do. And I can multiply both sides by 1/3. And I get t squared minus 6t plus 8 equals 0. If you factor, you get t minus 4 and t minus 2 equals 0. We set each one equal to 0. We get t equals 4 or t equals 2. So these are when the particle is not moving. C, we want to know what time intervals is it moving from left to right or right to left. Left to right would be when velocity is greater than 0. So we want 3t squared, and again, I'm going to use the factored form here. 3t squared minus 6t plus 8 is greater than 0. And we already showed we could divide it by 3. It's not 0 divided by 3 doesn't change anything. And I can factor. And I'm getting that. So I don't know if we've done this in class yet in the pre-calculus or not. This is how you do something like this. We're going to make a little number line. And I'm going to put t equals 0 here. And then we got like 1, then 2, then 3, then 4. And these are when it's changing when it's at rest. V equals 0 here. Which means between them, it's not. It's got to have a velocity. And the sign will stay the same in between each region, because otherwise we would have another 0 between them. So what we do is we pick test points. In each region. 0 is always a great test point. 3 is in between them. It's the only whole number or integer in between them. And I tend to like try to pick something big, so I'm going to pick like 10. 10 is pretty big compared to 2 or 4. And what we do is we plug them in right here, and we just want to know what is the sign of v of t in each region. It has to stay the same over the whole region. If we had another 0, or if the sign changes, if the sign changed, the intermediate value theorem, remember doing that? Intermediate value theorem would tell us there was a 0 between them. Between the sign changes. So the sign's got to be the same throughout. So that's why we just pick one point and test the whole region. And really what I'm doing is I'm not going to calculate the value. I am just going to plug in my t into this equation right here. Plug in here. And I'm just looking for the sign. 0 minus 4 is -4. And I'm just going to record that as a negative. 0 minus 2 is -2. And I'm going to record that as a negative. A negative times a negative makes this a positive region. Then I'm going to do 3. I'll do one here. 3 minus 4 and 3 minus 2. Again, we're looking for the sign. 3 minus 4 is negative. 3 minus 2 is positive. So this is a negative overall. And then when I do 10, 10 minus 4 and 10 minus 2, these are both positive. So this makes this overall region positive. So the velocity is positive from t equals 0. It started at 0 to 2 and 4 onward. T is greater than or equal to 4. In interval notation, we write 0, 2. Was the speed positive at 0? Yes, if I plug in 0 at t, it's positive at 0, so I can use that. in union with 4 to infinity. That's when it's moving from left to right. When its velocity is negative, it's when it's moving from right to left. And that's going to happen between 2 and 4. So 2 and 4 is when like the velocity changes. I'm going to just mark its position. I'm going to figure out what is its position when it started. And I'm going to rewrite my S real quick just so I have it. I don't want to have to scroll up a lot. We had t cubed minus 9t squared plus 24t plus 4. I'm going to find its position. To trace its path, I need its position at these points. So position at t equals 0. S of 0 equals 0 cubed minus 9 times 0 squared plus 24 times 0 plus 4. S of 0 equals 4. At t equals 2, S of 2 equals 2 squared cubed, sorry, not squared, 2 cubed minus 9 times 2 squared plus 24 times 2 plus 4. And when I do that, I get, let's see, this is 8 minus 36 plus 48 plus 4. 12 plus 8 is 20 plus 4 is 24. And S of 4. I'm just plugging in the 4 for all of my t's. When I do that, I get S of 4 equals 20. So maybe if I draw a number line, I'm going to give myself a little room. I'm going to show the position above the number line. So like if this is 0, let's say that's 4, 8, 12, 16, 20, 24, 28, and onward. At t equals 0, it's right here. At t equals 24, it's over here. So that does show us that we're moving to the right. Our velocity is positive from there. That's at t, not 4, t equals 2. But then it turns around and goes back to 20. And at 20, that's at t equals 4. And at that point, it turns around and starts going that way. So its motion is positive from there to there to there. It's negative from there to there to there, and it's positive after that. Okay. I'll pause this video here, or stop this video here, and we'll do a new one in just a second.